Hello everybody, welcome back. Okay, before we get started on the tube socket and air box, I thought I'd give you a look at what we had going here. All the switches are mounted and all the lights are mounted. So from right to left, we're actually upside down. This is the face of the unit right here. Flip this around, all these switches would be on the left, of course. Alright, first switch is power on. Second switch is their high voltage on and off, and it turns this relay. This is the power on relay. This is a high current relay. It's like 20 amps. The little switch can only handle about 6 amps. So the little switch runs this relay to turn your high voltage transformer on. And you don't have to use a step start on this size of a box, but there is still a little bit of an inrush. I think the amperage that the transformer will draw at max is probably 15 amps or so, but the relay will handle 20, and it'll take more abuse than the switches, I guess is what I'm trying to say. Anyhow, there's a fuse in line with the first switch. The little 2 amp turns the bias and keying supply and the screen supply. Of course, the transformer is on the other side of the chassis. Next switch is standby and operate switch, and then the sideband and AM switch. The staging switch, high, medium, low, and max, right here. I said that wrong. Anyhow, you know what I mean. I'm tired. I've been working all day trying to get this thing wired. Anyhow, 4-position switch. And it ties in back over to the voltage divider. Might not be able to see them too good. Let me try to point them out. I made a comment about it. The casing, if you use rotor cable, you'll have this gray sleeve tubing if you just pull the wires out of it, and it makes real nice hold downs. Let me tilt this a little bit. You see these things right here? Just little pieces of spaghetti. I've just glued them to the chassis. There's a couple here that are still floating because I didn't really know where are the extras. And they'll only handle about 5 wires, so I had a couple more wires needed to go through, so these will be glued down later, and I'll just set a weight on them after they're glued and hold them in place. But they're real nice little neat wire binders to keep your wire in like little bundles. They're just little tubes. You run the wire through them, and I placed a few of them around the chassis where I thought they would go. I see now it's a better idea to just slip them on your wires as you're putting them on, as you're wiring the wires. Then you can find out what the final position is after, but that's probably the best idea, is just don't glue them until you're all done. Then you can put whatever angle you need on them, and they'll all be in the right spot. Okay, I'm going to pause the camera and I'll flip this thing over and I'll let you see what the lights look like. Okay, we'll see if this works. I've dimmed the light just a little bit so you can see the light. The angle I've got it here, they're not too well visible, but I think with the light dimmed a little bit, if that still comes through on the camera. Okay, power switch, high voltage switch, standby and operate, and sideband switch. Okay, now I haven't got the high voltage circuit hooked up, but I can jumper the relay and make the rest of the circuit work so you can see what it would look like once your high voltage supply is in and the screen protection relay would close. So first off, we'll just turn the power on, and you see we got the fault light on. Okay, and see none of the other lights are working. That's all shut off until this light turns green. Alright, let me grab a clip lead and I'll go under here. Not easy. think that'll work. Alright. There. All lights are on and green. That's what it should look like when if you had high voltage. And there's standby. There's operate with receive boost. Operate without receive boost. And this is the sideband AM switch. Right now it's in the AM position. And we flip it to sideband, you see it turns red. This one would turn red if we key it up. And what I can do, I think I have my little radio ready to go here. Like so. I'll do AM first. That's AM. Sideband. You can see the mic in them. So there's what it looks like when it's keyed. And AM. Like so. And that's the power switch from the front side. Okay. That's wired just like I was explaining it, and you have the schematics. And any questions, I'll post my email address at the end of the video here. Like I say, you don't need to make it this fancy, but I thought I would at least make it with all the tricks that I knew. The only thing that I'm not using in here, because it's not needed, is a fan on timer, so that if you turn if you want to shut the unit down, the fan would stay running to take all the heat out of the tubes after the filaments have been turned off. But the 4CX250Bs are not that critical. They're tough. They can handle it. The tubes that you'd need to use that on would be like the 4CX1000 and the 4CX1500 and the 4CX800. Those are tubes that need to be cooled down because they've got a rather hot filament and they are a ceramic tube, and it's just better to get that heat out of them and instead of just letting them sit there and soak after you've turned the power supply off. Okay, when I come back, we'll take a look at the tube socket and air box. All right, here we are. Okay, what I'll show you first to point out, I'm going to start right from the little box's connector. I'm using a BNC on the copper-clad printed circuit board box. And the first thing it's going to come into is the tune grid load cap. And then the next it goes through the coil and through the grid tune cap. Then through a ceramic disc capacitor. And then over to the I haven't got it drawn in here. I've got them X marked in here. You can either use like a 47 ohm resistor in that place, or an RF choke, basically 250 microhenry, or enough turns of 28 gauge wire to fill a 1 watt 47K resistor. And that's what I've done in here. Okay. Right here, there's the BNC connector. Goes to coax on the inside. Stays shielded all the way up to the sidewall. And then right here is where it solders to the coil. And that white trimmer right here, that's one of them little pinch capacitor trimmers that's adjustable with a screwdriver blade. Okay, across the coil we go to another trimmer. This is the tune cap. Here's our disc, ceramic disc. It's a 0.01. And then into our parasitic choke. I got ahead of myself just a second ago. That I was telling you wrong, sorry. This is it's 3 turns of 18 gauge wire. I was thinking about the screen choke. I'll get to that in a second. Yeah, 3 turns, 18 gauge wire on a 47 ohm half watt or 2 watt resistor. And that's what I've got right here. 47 ohms. This is a small body 2 watt resistor at 47 ohms and 3 turns. The swamping resistor right in here I'm using on this rig comes out to 619 ohms. And it's a 5 watt resistor, 619 ohms. Okay, now we get to the screen. This is the small 250 microhenry choke you could use on the screen. That is, whoop, come on, get in the frame. That's off of the screen grid, pin 1 on the tube. This X2, well, get the paper over here, we're too far in. Okay, X2 is listed right here. This is what, 250 microhenry or enough turns of 28 gauge wire to fill a 47K 1 watt wire wound resistor. And that's that, right? I keep getting off center. Alright, that's that mark right there is what that means. Okay, then we got a 47K to ground, 3 watt. This resistor is here because on the screen line, this would end up connecting to your staging switch. If your staging switch gets dirty contacts, and in between stages, like you're going from, say, high to max, if there's a second that there's no contact made to that wire, you'll arc the tube because it'll just instantly go to plate voltage and you'll pop a tube. So what this resistor does is no matter what's going on this line, it makes sure that there's a little bit of current being pulled to ground to keep that screen from being turned loose. That's the one thing on these tubes you don't want to do, is ever release this line with no other load on it to hold this grid at basically 0 or real low voltage. It's just basically a protection. In operation of the tube, it's negligible. It doesn't do anything. The only reason it's there is for safety. You're just trying to protect the tube. So where that's at, right here at the end of the parasitic choke, right there, just going to ground. That's all it is a 47K. This is a small body 3 watt. Small body 3 watt. Just a carbon, or actually it's a metal film resistor. And how I always like to set these up so that I can check outside the box. I don't have to have wires going inside and a plug. I don't trust plugs. Molex are terrible for having continuity problems. So here's the outside look at the 2 terminals, and I've got these little tabs marked. G1 for grid 1, G2 is a screen, and F is a filament. Now how these, I don't know if they can see them, but I've scribed away the copper. I've cleaned it all off around a little square. I've just made a land there and polished it up with SOS pad, steel wool, so I could solder to it. Drilled a little small hole in the center and then shoved my wire from the back side and then soldered it down. That way you just bring your wires up here, you solder them on. And if you ever need to check, this is the outside wall of the box. You can take the side cover off, do your SWR tune here, and sorry, get that in frame. And if you ever have a problem, you can troubleshoot getting to right here so you can see what your grid voltage is, your screen voltage, and your filament. And all that's tied in. You can see where they just come through a little hole. Now what I do on the back side is I take a larger drill bit and I just by hand hold it in there, twist it, and it makes like a little funnel or a flare. It cleans the copper back out away from the hole. And then also when you run the wires through, you want to take a peek, look all the way around it and make sure the solder hadn't flowed to the copper, but your wire is centered up in the hole. There you can see the orange is the screen lead leading out. And on this particular one, I just got the end of the resistor. Goes right up. I straightened it out to where it poked straight through, held it in place, and then soldered it. And there's another disc. Yeah, there's a disc capacitor right there to ground. And that is this cap right here at the other end of the resistor going to ground. Okay, I'm going to pause the camera and hook up the SWR meter, and we'll tune and load this bad boy. Okay, hopefully that's visible. Alright, so we'll calibrate the meter. Flip it to reflect. Let's see, I've already got it there. Just dial it right down there. Whoop, too far. Close. Whoop. Sometimes you can get it closer by backing one off to where there's a little SWR showing, like you go past the center. Because you might be on the wrong side of the peak. About as good as I'm going to get it. Right there. Just barely has a deflection in the needle. And that's it. Now the tube's not in the socket. There's going to be a few picofarads added on the tube. I'm not sure, but it's in the neighborhood of 5 or 6. Maybe. Let me take a quick look here. I don't look at these things all the time, so I don't remember them. Okay, input. Oh, a little more. It's 15.7 picofarad for the 4CX250. So that'll throw this tuner off a little bit. So if you want, you could plug the tube in there without any voltages on it, and that'll add the capacitance that you need, and then zero these two controls out that way, you know, even before you put voltage to it. Mainly the resistor is sitting there looking and taking on the load. So like I say, when you add the tube, that adds a little more capacitance drawn across that parasitic suppressor. So that will throw you off a little bit. Not much. It's close enough, you're in the ballpark. Just barely a tweaking of it and it'll bring it right out to flat match again. Okay, well, I thank you for watching. What's next? Let's see. I guess I'll show the plate. This might be a little while before I can get to it. I got some personal stuff I have to attend to, but if I can, I'll try to get that in the next video anyhow. I haven't shown this yet. This is the high voltage capacitor stack. Let me zoom in a little bit. Hopefully that's not blurry. Maybe I can get it. Oh, that's max. Okay. This is a high voltage capacitor stack with the bleeders. I'm using 220K half-watt resistors across each one. But what I wanted to show you, if it's visible here, this is the ground side of the cap. This is the negative end of the supply. High voltage B+ is over here. The first cap off of ground is where you put your screen protection detector. It comes right off a 220K half-watt resistor, carbon or whatever you have. Then it goes into a diode. This is a Zener Diode. It's 64 volts. And if you can see, probably can't see the band, but the band is pointing towards the resistor. It's pointing towards the resistor. The idea is that it waits for that cap to charge up to at least 64 volts, and then the diode will avalanche and send power through the 220K resistor down to a little driver transistor. Again, you might not be able to see that. It's a little 2N4401, and it's driving an MJE3055. The emitter is grounded. The collector of the 2N4401 drives the base. It's basically, if you look up what a Darlington transistor is, it's in a Darlington configuration. The collector of the MJE3055 is where you tie your relay wire. On the other side of the relay, it gets tied to 24 volts. Whoop, I'm sorry. Get it in view here. The collector of the MJE3055. That's where you tie your screen protection relay. The other side of the relay goes to 24 volts. So when this transistor detects high voltage, it'll close that screen protection relay and allow your rig to go in to operate. So if you ever pop a fuse, or if there's a problem, the high voltage stack will go down. This transistor will stop to conduct. The screen protection relay will open. It'll remove it from the operate condition. Even if your operate switch is on, it just shuts everything off. You can't key it up, and that keeps you from damaging the tube. And in the way I have the front panel wired, the red light or fault, high voltage fault, will come on. And that was in the last video I showed the schematic and how the lights and everything were wired. But I thought I'd give you a look at the protection transistor. This is in one of the schematics already drawn out, so if you have any questions on it, look. It's in the early ones. Might be around number 11 or something. I'm not sure. I should keep a list out here so I can direct you right to them. But anyhow, any questions, you can just send me an email and I'll maybe try to help clarify it to you. Okay. I appreciate your following along so far. Let me back this out a little bit here. Come on. Cooperate. Okay. If you want to ask me a question, it takes a real long time to answer if you do it through YouTube, because I can't get into YouTube out here where I live. I'm off grid and my internet's real slow. So send me an email, radiomedic111yahoo.com. And if you feel that anything I'm teaching here is of value and useful to you, and you'd like to help out, anything would be appreciated. My PayPal address, honda-cb350@live.com. Okay, guys, like I said, the next video, we'll try to get to it, and that should wrap it up. You should have enough information to fire your rigs up. I'll show the plate pi tank network and the tune and load on it. Okay, till then, bye.